Okay, this is the solutions video for the first homework assignment in chapter 1. And we're on page 34 and 35. I will be just reading. I won't be putting the book in the underneath the camera the whole time. Just be reading it to you, except if we're doing a graph or something like that. So, review question number 1. So, please just correct your answers if you got them wrong. What's the main difference between a scalar quantity and a vector quantity? Well, a vector quantity contains directional information. Ooh. Whereas a scalar quantity has no directional info. All right, number 2 says, on a physics test, the first question asks the students to calculate the acceleration of an object under certain conditions. 2 students answer this question with the same number. The first student's answer is positive, while the second student's answer is negative. The teacher says they both got the problem 100% correct. How is this possible? Well, the students assumed different directions as positive. So possibly the first student said the right was positive and the second student said the left was positive. Now in our class, I'm not going to have on a test always assume that the positive is to the right or up. Okay, that's the way we're going to do it so that there's no confusion. All right, number 3. Okay, that one says, what is a vector quantity, speed or velocity? Velocity is the vector quantity. Number 4, what's the main difference between instantaneous and average velocity? Well, instantaneous velocity is a single point in time. Can't calculate it without calculus. Average velocity occurs over a period of time. All right, and number 5, what physical quantity is represented by slope in a position versus time graph? Well, that would be velocity. So the answer is velocity on both number 3 and number 5. All right, I'm going to erase this and then we'll go through the math problems. All right, practice problems. Page 35. Okay. Number 1 says a delivery truck travels down a straight highway for 35.4 kilometers to make a delivery. All right, let's say this way. 35.4. And on the way back has engine trouble. The driver is forced to stop and pull off the road after traveling only 13.2 kilometers back. How much distance did the driver cover, and what's the final displacement? All right, the distance is going to be the whole thing. So 35.4 plus 13.2. All right, what is that? That's 48.6 if I'm doing that right in my head. Don't forget the unit. Now the displacement would be from where you start to where you finish. So that's going to be 35.4 minus 13.2. So that would be 22.2 kilometers for the displacement. All right, number 2 says if the driver in the above problem took 21.1 minutes to reach the delivery point and broke down 7.5 minutes into the return trip, what was the average speed? And then what's the driver's average velocity? All right, speed is change in distance over change in time. We know the change in distance was 48.6 kilometers. And we know that the time is going to be 21.1 plus another 7.5 minutes. All right, didn't say we had to change this into meters per second or anything like that, so I'm just going to keep it like this. So that is 1.7 kilometers per minute for speed. All right, velocity, which is a vector, so we're going to put that little arrow there, is change in displacement over change in time. The displacement we figured out from number 1 is 22.2 kilometers. The change in time, we add those two up, so that's going to be, what, 28.6 minutes. So your calculator, your trusty calculator, will tell you that's 0.78 kilometers per minute. All right, look at us go. Okay, so we'll erase this and keep moving. All right, number 3 says that a plane flies straight for 672.1 kilometers and turns around and heads back. All right, and then lands at an airport that's 321.9 kilometers. The plane's average velocity was 42 meters a second. How much time did the entire trip take? So we know that velocity is the change in displacement over the change in time. So we want to solve for how long, change in time. Going to algebraically just switch those two. So that's going to be the displacement over the velocity. Okay, displacement is going to be 672.1 minus 321.9. Okay, it's not total distance, but displacement. So from here to here. And then velocity 42 meters per second. All right, so we've got an issue here that I kind of forgot to do. We need to change either this to kilometers or this to meters. So I'm going to go ahead and change. Let's bring this over here. Let's change that to 672,100 minus 321,900 meters over 42 meters per second. Got to be careful with those units. Luckily, I caught it. So that is going to be 8,338 seconds. Of course, if you decided to change 42 to kilometers per second, that would also work. That'd be 0.042 kilometers per second. So you just divide 42 by 1,000. All right, so that does it for number 3. Let's finish this video up with number 4. Okay, number 4 says an athlete runs 1,600 meters down a straight road. Over the first 800 meters, the runner's average velocity is 6.5 meters a second. Over the remaining 800 meters, his average velocity is 4.3 meters a second. What's the average velocity over the entire race? Okay, so our first 800 meters, okay, we have, let's call that V1. Is change in displacement over change in time. So I need to get the time. So change in time would be change in displacement over our original velocity. Okay, and that is going to be 800 meters and 6.5 meters per second. All right, so that gives you 123.1 seconds. And then we would have, so that's time one. Time two, I'm gonna just use this same equation. I won't do the algebra again. That's gonna be 800 meters, and our velocity for the second leg of the race is 4.3 meters a second. So slow down. So it's gonna take more time, and for that second leg, it'll be 186 seconds. So the total time is going to be 123.1 plus 186, and that is 309.1 seconds. So our average velocity for the entire race would be 1,600 meters, change in displacement, over the total time, and that is going to be 5.2 meters a second. Now I want you to write this down. Be careful here on this one. You might have been tempted just to average the two. Average 6.5 and 4.3, but that won't work. You can't just average the velocities. I'm going to have you go ahead and write this down. Because they didn't occur over the same time period. Okay, I hope you can see this, getting down to the bottom here. All right, since they didn't occur over the same time period, we had to figure out the two times and make that the total denominator. All right, that does it for the solutions video for Chapter 1 homework number 1. And I will talk to you on the next video.